Ever wondered how querying data in Hive works? Hive, my friends, is a powerful data warehouse infrastructure tool designed to process structured data in Hadoop. It's like a Swiss Army knife for big data, handling a variety of tasks with ease and precision. Imagine you're working with a mountain of structured data. How do you make sense of it all? Enter Hive. It provides a SQL-like interface to manage data stored in various databases and file systems that integrate with Hadoop. So you can use the familiar SQL syntax to deal with your big data. But here's the magic. Hive isn't just translating your SQL-like queries verbatim. It's transforming these into MapReduce jobs. This means you're leveraging the power of parallel processing to crunch through your data faster and more efficiently. Sounds intriguing, doesn't it? Let's delve a bit deeper. So, what's the magic behind Hive's querying capabilities? Well, it's all about the language it uses, which is known as Hive Query Language, or HQL for short. HQL shares a lot of similarities with SQL, giving it a sense of familiarity. But where it really shines is in its simplicity and versatility. HQL is designed to cater to those who might not be well versed in programming. This allows them to dive into ad hoc querying, summarization, and data analysis with ease. No need to wrestle with complex coding or syntax. The beauty of HQL is that it's user-friendly, making it perfect for beginners and experts alike. But don't be fooled by its simplicity. HQL is still a powerful tool within the Hive ecosystem. It serves as a bridge connecting the world of SQL and the vast expanse of Hadoop. So whether you're navigating the waters of big data or just exploring the Hive, HQL is your compass. HQL, a powerful tool in the Hive ecosystem, bridges the gap between the world of SQL and Hadoop. Now, how does a query in Hive actually work, you may ask? Well, the magic lies in its execution process, which is designed to handle even the most massive datasets with ease. When we run a query in Hive, it doesn't just dive in and start crunching data. No, it first creates an execution plan. This plan breaks down the query into a series of small tasks, each of which can be executed independently. Think of it as a chef preparing a complex meal. The chef doesn't just start cooking, they first create a plan, breaking down the recipe into a series of manageable steps. Each of these small tasks can be executed independently by what we call a mapper or a reducer. These are the sous chefs in our kitchen analogy, each handling a specific part of the recipe. The mappers handle the initial data processing, while the reducers take the outputs from the mappers and combine them to produce the final result. But how does Hive know which tasks to assign to the mappers and reducers? That's where the execution plan comes in. It sets out the sequence of tasks, and Hive then translates this plan into a series of MapReduce jobs. MapReduce is a programming model specifically designed for processing large datasets. It's like the restaurant manager who oversees the whole operation, making sure each sous chef knows their tasks and performs them in the correct order. The beauty of this process is that each MapReduce job is executed in order, with Hadoop, the big data framework, managing the whole show. The output of one job becomes the input of the next, like a well-oiled assembly line. This process may sound complex, but it's what allows Hive to handle large datasets so efficiently. It breaks down the data processing into manageable chunks, allowing for parallel processing and thus speedy results. In essence, Hive's execution process is a masterclass in efficiency and scalability. It shows how large tasks can be broken down and managed effectively, making it possible to process large datasets with relative ease. Hive, with its clever use of MapReduce, makes querying large datasets a breeze. What should you remember about querying in Hive? Let's summarize the key points. Hive is a powerful tool designed for querying extensive datasets that are stored in Hadoop's Hadoop distributed file system and other compatible file systems. It's a potent tool indeed, but what makes it truly accessible is its language, Hive Query Language or HQL. It bears a striking resemblance to SQL, a language many of us are already familiar with. This similarity makes Hive a comfortable and efficient option for those who already speak SQL. But where Hive truly shines is in its ability to break down complex queries into a series of manageable MapReduce jobs. This strength enables Hive to efficiently handle large-scale data processing tasks. Hive takes the heavy lifting out of big data, simplifying the process of extracting valuable insights. So there you have it. Hive a bridge between the world of big data and those of us who speak SQL. Happy querying!